What's up, guys? Thanks for watching this. This is a sample video for the Advanced Functions course in high school. So the course code is MHF4U. I'm pretty sure you have written your first and second unit test. Now this is the polynomial inequality which you will face in the third unit test. So pay attention to this, okay? You will see a lot of question like this on your test or quiz or in the exam. This is a very typical one. Now, when you face such inequality question where you have one polynomial on one side or the left side and the second polynomial being on the right side, your first job is to move everything to one side. So what we're going to do today is first we're going to move these to the other side. Now remember this, when you're moving these to the other side, you're changing the sign of every term that you're moving. So we have x to the power of 4, 3x cubed, minus 7x squared, minus 15x, plus 18 is greater than 0. Now remember, when you're moving terms, you're not changing the direction of the inequality opening. Okay, you only change that when you are dividing or multiplying it by a negative number. So remember that one, okay? That is quite important for you. Now, once you have everything moved to one side, all you have to do is just to simplify as much as possible. Thankfully, in this case, everything is simplified and we don't have to add any other like terms. Once you have that, all you have to do is you factor them fully, completely fully. So when you're factoring polynomial, the easiest possible way is to use the factor theorem as well as the synthetic division. So in this case, 1 will make the whole expression 0 because we have 1, 3, negative 7, negative 15, and positive 18. So that becomes 0 when you add all of them up. Therefore, when you start the synthetic division, your divisor number should be 1. Now we have 1, 3, negative 7, negative 15, and 18. These are the coefficients of each term. So basically, then bring it down and times by the front number, then we get 1, add it, and then multiply it, and then add it again, multiply it, add it, and then multiply that again. Now, then obviously the last number is a remainder. A lot of students actually don't put any indication for the last number, but it is actually wise for you to do it because that way you don't get confused to whether that's the remainder or that's your last constant term of the quotient. Now, you won't do that. You won't make any mistakes when you're doing a homework, but when you are doing a test, you're under pressure, right? So your brain sometimes works in a slightly different way, or there's a glitch and you forget that. So make sure you put that little indication or fence per se around the last number indicating that that is your remainder. Now, then we have x minus 1, x cubed plus 4x squared minus 3x minus 18 still greater than 0. We haven't done any multiplication of negative or division of a negative number. Now, we still do have x cubed and 4x squared, negative 3x and negative 18, which is not the easiest possible format. So let's see whether we can factor this one again. So we plug 1 in it. We get then 1, 4, negative 3, and negative 18. It doesn't make any 0, so it violates the factor theorem, so we're not going to use 1. If we use negative 1, then it becomes negative 1, 4, 3, and negative 18, same way. Then move on to negative 2, positive 2, so because 2 is a factor of 18. So we get then 8, then this becomes 4 times 4, 16. This becomes negative 6, this becomes negative 18. And this way, we get 0, right? So then this is the factor theorem. We can use the synthetic division again to factor this fully, okay? So I'm just gonna go back one more time. There we go. There was a little glitch with the OneNote. So we are gonna use 2, right? We're gonna use 2. So we have 2 as the divisor. 1, 4, negative 3, negative 18. So there will be 1 times 2. So, and then we keep doing it. And then we get 9 and then positive 18. So there we go. We have the second factor of this long quartic function. So we have x minus 1, which was the very first one. And then x minus 2. Then we have x squared plus 6x plus 9. Still greater than 0. Now, if you look at this, this is, hopefully you recognize it easily This is a perfect square trinomial. So we have x minus 1, x minus 2, and then we have x plus 3 squared, which is greater than 0. Now we're almost done. We factored it fully. So depending on who the teacher is, or depending on who you are or your preference is, you can use a table or you can use a number line. I'm going to show you the number line way because it is a lot shorter per se to me. Okay, it's a lot less of work. So what we do is we first have to find the zeros of each brackets, each part. So we have 1, 2, and -3 as the zeros. And then on the number line, we put these. So -3, 1, and then 2. Now make sure you have enough space between the numbers. After that, all you have to do is you choose any number that falls in, let's say, this interval that is less than -3. So in this case, I'm going to choose -4. Now, when you choose a number, it doesn't really matter what the actual number is. It's just whether you have the negative sign or the positive sign that matters, okay? So if I choose -4, the first one will yield a negative sign. The second one will also yield a negative sign. Now the last one, it doesn't really matter, don't you think? Because we have a square. So whatever the number I choose, it will always yield a positive. Anything squared is always positive. So this is negative times positive. So then that becomes a positive as a whole product. Now the second one, we have -3 and 1. So let's choose this time 0, which falls in between these two numbers. And 0 yields the first bracket's negative, second bracket's negative, the last one positive. So this also gives me positive. Now then the 1 and 2, 1.5, we can choose that. So the first one will become positive, second one will become negative. Then the third one is again always positive. That yields negative. Now then the last one, we have 2, so that will be, or bigger than 2, positive, positive, and positive. So that yields positive. So we're almost done. Now this one, we just need to put into the interval mode or the inequality mode. It's up to you. We can say the answer here is then x is less than -3, and from -3 to 1, and then x is greater than 2. If it was the interval notation, then obviously -infinity to -3, not inclusive, because our inequality is not inclusive, u. So then -3 to 1, u, and then 2 to positive infinity. Okay, so hopefully this helps you understand how to do these type of questions. All right, talk to you later, guys. Bye.